And it all fits into a compact, easy to carry case. And here it is. Just kidding, it is not a TI-85, although it is a calculator, kind of. No, it is the very unusual HP-85, a calculator computer thing originally released in December of 1979. Now it is slightly different than the other computers, the old computers I have around here. You have your Tandy, your Apple, your cheap home computers, and then there's the business machines, databases, spreadsheets, all that sort of stuff. And then the IBM PC came around and you got that covered. But this is probably best described as a scientific personal computer. Something for someone who needs to do a lot of very precise calculation type things. Look, you get everything you need. A small inbuilt black and white CRT, full-size keyboard with a bunch of extra bonus keys that are not on any regular computer, built-in thermal printer, and a built-in tape drive. You know, this thing reminds me a lot of the IBM 5150, the difference being that this one has not been snatched up by all of the world's time travelers, and if you're so inclined, you can still find these out there. Now you might say, surely this thing is massive for a portable computer, especially compared to the calculators and other small form factor things that would come around not 10 years later. But at the time, this was actually very compact. Here's an Apple II for comparison, and this one doesn't have a built-in screen. The disk drives are external, no printer. You basically, you get the keyboard. Although those of you who know your history will recognize a connection between the two of these. Very famously, the engineer for the Apple II, Steve Wozniak, was working at HP at the time, a few years before this came out. And he offered to HP the rights to the Apple I, which at the time was kind of a hobby computer. HP, of course, turned them down. And nowadays, Apple is the richest company in the world, while HP makes printers that require a subscription. If you go and look up the HP-85, you'll only read about that it's the computer that HP built after they turned down Apple. So surely they made a huge mistake. Well, I say not really. I mean, what would you do if you have a laboratory to run? Are you going to buy some nerd science project? Or are you going to buy a computer from the same people who make the rest of your lab equipment, like this oscilloscope or this spectrophotometer? HP made everything from atomic clocks to multimeters. They could make all their own custom chips. They designed a custom CPU for this machine. And, just everything about this is very highly polished in a way that Apple is not, including the software. I'll give you an example. Finally, someone gets it. You also get 12 digits of floating point precision, which is actually 15 digits internally, including trigonometric functions. And all the arithmetic in this is done with decimal and not binary. HP was king of scientific calculators. They also made mini computers, and sort of the obvious choice for a desktop computer is something that's sort of in between the two. After all, if you think you need a desktop computer and you're not using it to do calculations, why do you need a computer? But this is no simple calculator, because there was all sorts of I/O options you could get to connect to whatever it is you need a computer connected to, whether that's serial or there's a digital I/O card that I don't have, or HPIB, also known as GPIB, not only for connecting to your floppy drives, printers, and plotters, but also the rest of your laboratory equipment like multimeters or oscilloscopes. Now, being 45 years old does come with its fair share of 45-year-old problems, although this one mostly works. I was very surprised that the printer works. Those are normally known to be bad. But the tape drive has a rubber piece that has dried out. I've never had a computer with a tape drive, so I definitely want to fix that. I look in there. That corroded thing was once the rubber drive wheel for the tape. You also won't be able to use the cartridges HP made because those have all disintegrated, but you can use a DC 2000 cartridge, which, I mean, these are 30 years old now too, but they're in a lot better shape. They're a little bit different though. And the difference there is that this little drive wheel there is physically located further up than on the HP cartridge. And so likewise, we need to move that drive wheel up also. Now for my tape repair attempt, I'm going to be closely following HP Extraordinaire and YouTuber Curious Mark series for this, who about 10 years ago put together a series with the exact steps I need to do to get my tape drive working again, including the modifications to get the DC2000 cartridges working and the potential for belt replacement in those. As far as I know, he's the only other person to capture this process on video. I'm actually going to get to attempt the tape drive repair part of it twice, because the first time I did it, it didn't work for me. So I went with a little bit more robust method. You can skip over this first part if you want to. You just have to undo the front part, and then it can come out. Oh. There we go. All right, let's get a closer look at that. So there is the drive motor, which is just a normal brushed DC motor. And I believe this uses a printed wheel encoder and an LED and some kind of photodiode to get an encoder. So it's a servo motor. You'll find the same mechanism in some HP plotters of the same vintage. Really, even in the modern printers, it sort of uses the same thing. But yeah, there's that decayed drive wheel there. Very crumbly. And the next step is to take this motor out. And there are 4 screws and also the either the photodiode or the LED. I think you can just pull these out. I'm not sure. Yeah, it's like a socket. There's the other one. Ooh. Soft, just like that. And yes, there is that encoder wheel, which is something I do not want to mess up. This is the smallest size on this thing. Inches, of course. It looks like 50 thousandths. And in theory, it pulls right off. 6G in here. None of that 5G. It may have been a bad idea to go with a brush on that, but if nothing else, the roughed up end surface here should take glue a little bit better, or epoxy rather. Alright, it's still a bit oversized, but this is going to be the extension, and the idea is I'm going to epoxy it on just like that. This can go in here. Actually, I'm going to coat this with wax first so that none of the epoxy sticks to it. Alright, that should do it. I can feel the wax is on there. Now, this is going to go in like that. pretty good so far. Put a couple clamps on there. It's pretty good. All right, it's the next day. The glue has hardened. Epoxy has hardened. Oh, interesting. It doesn't stick to this tape. Well, anyway, with any luck, I should be able to get this drill bit out. Just like that. And now, the hole in this end is now aligned with this hole. So, we can use the live center on it. The new tire will be a standard O-ring, probably this one. And the number that everyone seems to come up with on the forums is about 10.7, 10.8 millimeters. And now I just have to find something suitable for cutting an O-ring groove. Probably don't want something too sharp or too shallow. I have these nice circular ones, but there aren't any small ones. So probably want like a V cutter. Where along here does the O-ring groove go? Goes something like that. And you'll notice that the little wheel in there touches right up against the brass. I believe there's a little bit of spring retention here that holds it against the rubber wheel, so it's not quite as close. But then I'm just going to take something sharp. It actually ended up being easier to do with an X-Acto blade, but sure enough, right there is the mark. And because I know that the wheel is 2.4 millimeters thick, because I can measure it, then the groove will start exactly halfway in between. All right, looks pretty good. And all without damaging the grating. I've been told there's 500 slits in this, but I'm not about to count them. Alright, I'm not exactly sure how much space you're supposed to leave. I tried to leave this much. Oh look, you can see a moire pattern in there. That's promising. Let's try it with the light. Yeah, seems to be working. And okay. Seems to be retained. Pushes up against the tire. I do notice there's a little bit of a gap here. I don't know if that's too much or too little. Now, there is at least one other quality of life item here, which is related to this hole right here. See, because this is taller, this flap thingy is taller also, and it will sometimes catch right on that, or it will catch on the PCB behind that. Very smooth. Well, I suppose we should see if it works, huh? Haha, you didn't think I'd get away with it that easily, did you? Nope. There's a circuit modification to do. Between these 2 points is a resistor to which you add in parallel a 1.8K resistor, like that. And if I've got this right, this has something to do with the write current. Obviously, the 40 megabyte cartridge is a different tape formulation than the older HP one, which I think holds like a couple hundred kilobytes or something. So this resistor makes it possible for them to be written. Now, one thing that does not hold up is these. The backing is coming off some of them, but I'm going to try to flatten them out and hope that it can survive another reinsert or two. Okay, now C tape. Oh my gosh, it's working. Well, that's promising. I think erase tape is sort of how you format the tape. Let's see what that does. Did something. Well, I was messing with it some more, and then this happened. Looks like that epoxy did not hold. Back to the lathe for this one, and the next thing I'm going to try is I'm going to turn this down and then go for a press fit sleeve over it. And I happen to have this .239 reamer, although it measures in at more like .24. And I'm no expert in press fits, but from what I've seen, at this size, I want to go about 0.02 over here, so this will come in, you know, .242, 243, something like that. And we'll see if we can't get a press fit on there. If not, it'll be a super glue fit. Alright, I got this coming in at 243 even. Okay, good. It doesn't fit. of truth time. So I'm going to try to push it together in this vise. I have this little piece of paper to protect the plastic encoder wheel. Best case is that it presses right on like it's supposed to. Worst case, the whole thing gets bent and I have to recreate the entire drive capstan from scratch. Let's see what happens. It's about 18.6. A little bit lower. Well, let's see how this fits. And that is too tall. Got to go down probably another 1/2 millimeter. That one there is probably a bit high, but I think it's okay. Better than being too low, I think. We're back to this insanely difficult part again. To somehow push these wires into that socket. That one went. That one went. Well, at this point, I think we're only dealing with bad tapes, probably rubber band not being tight enough issues. So I feel justified in putting the cover back on. I don't think that one is going to come loose anytime soon. All right, well now it's on to the cartridges, because despite the tape drive being fixed, I'm having some problems with these. Now, while these are new, and some are still in the package, they are still old. I mean, this Olympics is probably from 1992. And what it is, these have a rubber belt in them, or plastic, some kind of formerly stretchy material that is not quite as stretchy anymore. So let's open one of them up. This one is already messed up. The tape already came out and it's gotten damaged, so we'll start on a not good one. So there's actually a very interesting mechanism inside. When I first saw these, I was a little confused because, as I said before, there's no capstan. Instead, there's just this little drive wheel here, and it uses a belt. So how does it keep the tape going at a constant rate if there's no pinch roller and capstan? And the answer is that this belt goes on the outsides of the reels like that, and it's turned by this wheel here. This is what that little rubber drive wheel actually turns. So it's only touching the outsides of the reel, so it's touching the tape here, and it's touching the tape here. And because it's one continuous belt, it's the same speed all the way across, so it unrolls this reel at the exact same rate that it reels up this reel. And so the tape goes across at a nice smooth speed, regardless of how full this reel or that reel is. Now, despite what I just said, the real black magic is this. If there is somehow a little bit of slack in the tape, let's try to get some there, then just by winding it back and forth, it will somehow magically take up this slack. Even though, as I just said, the belts make both of these reels look, at least look, I'm sure they're not moving at the exact same linear speed on the outside edge. Now the patent says that this has to be stretchy for it to work, this belt. But apart from that, I'm completely lost. Regardless, it's the belt that's the actual problem here. It isn't very stretchy, and it's not got a good grip on it, so when you come to a sudden stop, I found in the machine does, goes for a while, and then suddenly stops and reverses. And when that happens, you get, one of these will keep moving and will slip, and then you'll get some of that slack, and it just keeps happening. So it's the belt that is the problem. And if I take the belt off, you'll see it is not very stretchy anymore. I don't know how stretchy it's supposed to be, but it's not. The other thing I noticed about these belts is that it seems like one of the sides is sort of has more stretch than the other. And I was wondering why that is. So apparently that's what they did to make the belts, minus the laser. They were punched out from a flat sheet, and then you got a ring like this, and then they took this and stretched it into a flat belt. It's inside out. Like that. And that's where your weird one side smaller deal comes from. I suppose I could do the same thing, although they probably made their belts out of something that wasn't plastic garbage. Now, as to where to get replacement bands for them, I do have a whole bunch of these Travan tapes, which are also that same QIC belt-driven deal. Let's open one up. These do not fit in the machine, they're a little bit wider, and they also have a lot more tape. And the belt is bigger, but this belt is still stretchy. I mean, these are probably 25 years old instead of 30, but they're in a little bit better condition, I guess. I did try a couple of these with this bigger belt, and it did seem to work. However, the consensus on replacement belt seems to be these guys, Plastibands. They don't have that rubbery feel. I don't think they ever dry out like a rubber band does or disintegrate. They seem to be, they feel like they're made of silicone, and they still have that slick silicone-y surface on them. I wonder if that should be wiped off. And these are the 4 1/4 inch size, supposedly. All right, well, I'll have to be more careful about it with a tape that's it's actually still good, and I don't want to ruin, but it does seem like it goes on there. I guess the idea here is that this is stretchy enough that on those rapid direction changes, this has a little bit of give to it so it doesn't slip off of the belt. And there we are, 5 plasti-banded tapes. Now if they work, it's kind of nice that you'll be able to do, tell them apart by color. Got a couple of stalls. I think that the combination of the new belts and the O-ring is just like a more gummy solution that's a little bit higher friction. Plus it's old. But I just tried it a couple more times and it did complete the C-tape all the way to one end to the other. So I can try erase tape now. Done. If I do cat, yeah, there's nothing on it, but didn't have any errors. So that's a good tape right there. Probably. Now, of the tapes that work, I'm still getting a lot of stall errors. And then I took some of them apart again. And I've noticed, if you look closely right here, there is remnants of grease, or what was once grease. So I just went back and added a little bit of PTFE grease to all three pulleys, and that seems to help quite a bit. Although you have to run the C-tape a couple times, run it all the way through, get those that grease I added nice and distributed. But it does seem to work. All right, well, out of the 10 cartridges that I got, I managed to get 5 of them with that seemed to work without the tape being all screwed up. So yeah, Plastibands, a win-win. I don't know what that means in this context, but with replaced belts and greasing the rollers, did seem to get a few of my cartridges working. Will they work the next time I try to use them? That is a great question. I don't even know what's going on here. And now next I'm going to move on to something a little bit more advanced, which is around back here where your fancy I/O interfaces go. And really to do anything that's not, basic mathematics and stuff that's built into the computer, you need ROMs. So it's not just the interfaces that you need, but also the software. And this computer only has 16K internal and then another 16K of RAM right here. So it's not like you're gonna load, say, a print driver into RAM and have it work that way. What they did was make little ROMs that go into this ROM drawer. Although mine is empty because I don't have any ROMs, but they kind of looked like this cover and they would go in right here. And you'd have your ROMs. Now, the ROMs are sort of still out there. I mean, not really. They're on eBay at like 50 bucks a crack, if you can even find the ones that you want. So if you don't have the ROMs, what are you gonna do? Well, probably the selected option in the modern day is to use the incredible Everything But the Kitchen Sink project, which puts this teensy microcontroller on an interface board. And that goes in the back like that. This board does everything. If you don't have your memory module, you don't need it. This will do it. If you don't have ROMs, it'll do the ROMs. If your tape drive is broken, it'll do tape drives. It'll emulate floppy disks. This is an incredible board. I'm very happy that I have one. However, as with sort of any of these modern software, microcontroller emulated things, it kind of gives me that suspicious feeling, like when all of your problems are solved too easily. There's a certain imbalance that's going on here. So like this microcontroller is 1,000,000 times faster than this entire computer, probably literally. And the SD card has like 100,000 times more storage. And it's at this point where your personal philosophy enters the picture. Like, if this is so much more powerful and it can do everything, including probably emulate the whole system, is it any better than using an emulator, but you're still using real hardware? I need this board for my HP 86, which is sort of the same thing as the 85, except it doesn't have a built-in screen or tape or printer. So really, it's kind of boring compared to the HP 85. And sure, I could buy another one of these boards for my 85, but I just want to mess around with the hardware. You know how it is. Now, if you think I'm insane for doing this, I'd simply reply, well, if I was sane, I probably wouldn't be trying to use computers from before I was born anyway. Well, at least up to a point. I mean, I'm not going to go on eBay and track down every single ROM I need, because that's expensive. But that raises the question, well, what are your solutions for ROM if you want to do it in hardware? So when I first got this machine, it's okay, here's your ROM drawer, right? And then the ROMs are little chips like this, about this size. So you get some EEPROMs and program them and then make an adapter that goes in here, right? No, not even close. Because again, HP controlled all of the chips in this. So when they went to make their ROMs, they made their own ROM chips with their own I/O stuff on them. So an EEPROM like this, it runs on 5-volt TTL. You put in address lines, you get out data lines. You have a line that tells it when the chip is active, and that's pretty much it. If you're working on a Z80 system, it's super easy to interface with this. But on these Series 80 machines, that bus is 6-volt data lines and 12-volt clock signals. And you don't get a nice, address and data lines brought out for you. That's all multiplexed on the 8-bit bus, and you have to divide it up yourself. And there's no line to select which chip you want. You have to do that yourself. HP could do it on their ROMs because they made everything, and so they could just make ROMs that work with this bus specifically. But if you want to use a regular EEPROM, you're going to need some more hardware. Now it turns out there's already a solution out there for if you want to use EEPROMs in a Series 80 instead of mask ROMs, and that's the programmable ROM drawer. HP actually used this themselves. They made a spectrophotometer and had an integrated HP85 controlling the whole thing, but it wasn't high volume enough to have the software be on a mask ROM like all the other standard ROMs, so they just used a programmable ROM drawer instead. Now those cartridges aren't common. I don't have one, but there are pictures of them online. And if we open one up, you can see where the ROM chips go, but also all the other logic ICs that are in there. They're the ones doing the level conversion and the addressing and all the other stuff you need to get an EEPROM to work on a Series 80. Those dip switches are for setting sort of the slot that the ROM goes in. So the computer sees all the ROMs as one of, I think, 254 banks. And if you're writing a ROM, you're like, okay, this ROM has to go in bank 17, so you set the dip switches to 17, and then your ROM is in the right spot. But seeing as how the masked ROMs are rare, and the programmable ROM cartridges are probably even rarer, it's not really surprising that the community would come forward with a couple of efforts to recreate the programmable ROM drawers. One of those efforts was in 2008, where someone took an original and traced out the PCB, and then made a prototype on perf board. And then later, I think it was in 2019, someone came around with a PCB. But again, that's still the original ROM cartridge that could hold only 2 images. If you want the 6 of the original, or more, then you have to do something else. There was a project out there which was an FPGA that basically condensed all the logic ICs into one FPGA, and the ROM images were still on an EEPROM, but it was a bigger EEPROM. That kind of still gives me the sort of too modern, too easy approach to things, but that's kind of a moot point anyway, because I'm pretty sure the guy who made these isn't making them anymore. So my approach ends somewhere in the middle, mostly going off the reverse engineering work to make the original programmable ROM drawer. It's all of the individual ICs, although in surface mount, because I personally find surface mount easier to work with. But I like the idea of having a whole bunch of ROMs on one chip, so I went with a flash chip here. Mine can hold 16 ROMs, at least in theory. And then if you put a bunch of ROM chips on one chip, you have to do address decoding, and I used a programmable GAL chip for that, which is kind of like a very dumb FPGA, and is sort of period correct. I mean, these were around in the early 80s. But the thinking behind that is, if I'm going to pull this chip to put more ROMs on it, I'm going to have to reprogram it in the programmer. Well, I might as well just rewrite the logic equations and then reprogram this chip too. And then I don't have to mess around with any kind of dip switches or anything. And yeah, most of the logic is in the individual logic chips. All this one does is address decoding and then latching to the correct bank inside of this chip. So, if I have slot 17, that'll be the first 8K. If it's slot, say, I don't know, 29, that'll be the second 8K, whatever. The interesting thing about that is you can see which internal bank is being used with these LEDs, which is kind of cool. You can see which ROM's being used at any given time by the computer. I did make a couple of mistakes with this board. Number one, I used a footprint that's too big for the chips that I have, which, I don't know, they still fit in there, so that's okay. And then I messed up a wire, so there's just a hole there now. And if there's a third mistake, it's making this board a little bit too big so that it sticks out further than the original ROM drawer, which aesthetically looks a bit off. So when I make a 3D printed case for this, it'll stick out a little bit, but oh well, what are you gonna do? This was actually a pretty quick board to put together. I mean, most of the work was already done, and then I just slapped it in my favorite auto router and ended up with all these crazy traces, which is not super optimized for signal integrity, but this is a 600 kilohertz machine, so probably not gonna matter that much. I guess it's worth going over very briefly what the thing does, and keep in mind this is the same thing that the original programmable ROM cartridge did, but it basically does four things. Up front here you got your level converter chips that convert the 6 volt and 12 volt signals to 5 volt. The original was 5 volt TTL, mine is all CMOS chips because those are cheaper. Then there's various logic gates around that determine whether you're supposed to be reading from a ROM. Then there's the address decoding, as I discussed previously. And then these four chips here are a 16-bit counter for the ROM addressing. So remember I said earlier, if you have an EEPROM, you give it all the address lines you want, and then you get 1 byte out. Well, on this thing, if I were to do that here, it'd be the computer tells me a ROM address, then it gives me the data, I read that in, then I have to tell it the next ROM address, and then read it again, and so on. With the counter, I can just say, I'm going to read the first byte, and when I read it again, please increment to the next address. So I can just read continuously and read in a whole ROM that way, and not have to send it addresses every time. The only real special feature mine has is I brought out one of the extra pins on here over to this jumper. So if I pull this out, then the service ROM is active. And normally you wouldn't want that because then you start the computer up and it goes into the service menu every time if that ROM is in there. Now I should also know that I went back later and tried the service ROM tests for the tape, and it always failed. But then I copied something like this golfing game to the tape, and which is a pretty big program. I mean, it takes up a lot of space, has some graphics stored on the tape, things like that, except my frame rate is goofy. But yeah, somehow this loads off the tape just fine, no read errors, and obviously I didn't have this pre-written, so it had to write this tape too, again with no errors seemingly. So I don't know exactly what's failing in the service ROM stuff, but yeah, the tape seems to work, sort of, except they always get stuck and break like every 10 minutes, but aside from that, it works. But with the card installed, if I turn on the computer, you can see it go through and find all the ROMs that are in there. This is it checking to see, which ROM it is. And it takes a couple seconds, but now it knows about all the ROMs that are on there, which I think there's like 10 of them. I can also try typing in some basic commands, which is kind of risky because I didn't read any of the instructions for any of the ROMs or the instructions for the base system. But I can try typing in mat, which is part of the matrix ROM. There's a command in there. And some lights blinked, and it gave me an error, which is not surprising because I didn't type the correct thing in, but I'll try typing in frame. Frame is a command in the printer and plotter ROM, I think, and it draws something on screen, presumably what you're plotting, but see right there you get the printer and plotter ROM lights lit up. Another way I know that it works is because if I run this golf game thing again, I believe that uses the mass storage ROM to load the play field and stuff. So if I look at it, tape is going and we get some ROM action on there. So it's definitely using something that's not built into the system. And if I unplug this, I take that card out, it doesn't work anymore. So it's It's definitely working how it's supposed to, and I'm pretty sure I got it correct. So that's going to do it for the ROM interface card that I made. I'll post this on my website or on GitHub or something if you want to make your own. I'm not sure if I'm going to fix the issues with it because I only need to make one of these, and now I have it. So that's all done. But it's open source. You can fix it yourself. And I think I'm going to call it here for the HP85 as well, even though I have yet to actually write a single program on here, really. And I was going to figure out something with the plotter and I don't know, but I've been working on this for like 3 weeks and there's other projects that require my attention. So we will be coming back to this at some point eventually.